In this video, we're going to use MATLAB to be able to work a little bit with sequences. And so we want to try to plot the first 100 terms of this given sequence, a sub n equals n over the square root of n squared plus 1. Then we're going to use MATLAB code to find the limit of the sequence, and then we're just going to ask if it corresponds to what we got for the plot, why or why not. All right, so I'm going to click a new script. All right, and what I'm going to do is clear all, as there might be some variables in there. I'm going to clear the command window. I'm going to start by defining I'm going to go ahead and start by defining n as 1:1:100. And what this means is that n is going to be equal to the integers 1, 2, 3, all the way up to 100. Okay, so essentially the first one is the starting point. This one tells you the increment, so it's going to go up by ones, and then this is the terminal value. A sub n is going to be equal to, now remember, whenever we use these sorts of row vectors, we have to use dots to make sure we're doing scalar multiplication. So I'm going to say n dot divide square root of n dot squared plus 1, right? So that's going to be this sequence right here. And then I'm just going to go ahead, let me suppress this. And then I'm just going to say scatter a sub n comma n, or n sub p comma a sub n, all the way around. All right, so let me just run this just to show you everybody what that looks like. I'm going to save it. And it might just take a moment, so hang tight while it runs. All right, and then there's our plot, okay? Now, of course, we could expand this, and that's the first 100 terms of the sequence, all right? Now, we also want to label the plot appropriately, so let's title it. So we're going to say that this is the plot of the first 100 terms of a sub n is equal to n over square root of n squared plus 1. And then we have our x label. And I'm just going to call it n. And then I'm going to have the y label, which is going to be a sub n. All right, so I'll run it again, and we should now have a really nicely labeled graph. All right, so I'm going to go ahead and run it again. Again, it might take a moment, but shouldn't take too long. All right, so here is our title, and then now a sub n is going to be the y-axis, and n is going to be the vertical axis, or horizontal axis, excuse me. Notice that the numbers are approaching 1. So it seems like that the limit should be 1 for this. All right, so next part I'm going to do is I'm just going to go ahead and find the limit of the sequence. Okay, so let me clear all out. All right, so I'm going to go over here. I'm going to clear all. And then I'm going to make a symbolic variable. So sims n and a sub n. And I'm going to define a sub n to be n divided by square root of n squared plus 1. Okay, so just like we did before, except no dots because I'm not doing any computations this time. I can find the limit of the sequence by saying limit of a sub n as n approaches inf. All right, so we're just trying to find the infinite sequence limit. And if I run that, we still have the same exact plot, but down here we get the limit of 1. All right, now what I'm going to do is I'm just going to define this as a variable. I'm going to call it lim1, and then I'm going to get a nice fprintf, and I'm going to say the limit of this first of the sequence. So limit of the sequence is %s /n, not \n, and then comma lim1. Right. And remember what that does is that whenever it sees %s, it's going to call this lim1. Okay, so that's the parameter. %s is string. So that way, and sometimes MATLAB gets confused if you try to use like %n or %f. I just use %s whenever I have like an analytic value. There we go. Right. Now, the last part of this is, does this correspond to the above plot? And clearly it does, because both of the limits are 1. Okay, so the last thing we might say is f print f, and we would say, since the graph or the graph illustrates a likely limit of 1, and the analytic value is 1, yes, it corresponds. All right, and then I'll do a /n, so that way it knows I'm going to the next line. So I'll just go ahead and run this one more time. All right, so I'm going to go ahead and execute this. All right, so the limit's there. I spelled f print f wrong, probably among other things that I spelled wrong, but I forgot the f at the end of f print f. So one more time. All right, so there we go. All right, so this is a way that you can just use MATLAB to work really nicely with your sequences, both analytically and graphically. Okay, now in the next video, I'm going to illustrate how we can go through and see if MATLAB can help us to be able to find the sums of series if they exist.